My name is Flash Isaac, and I'm a teacher from the future. Hello, you're welcome to episode number 81 of the 120 Days to Jamb Physics with Flash Isaac. Like I always say, this is a series, which means no single episode can actually stand alone. You have to start from beginning and keep watching. That is when you get the best out of the class. And I also said that after every episode, I look at the information that might be missing or where you may be confused. I reorganize, then make it clear in the next episode. In the last two episodes, I introduced the electric cells. I talked about the fact that cells can be primary or secondary, and I gave the similarities and differences between them. And I told you that when cells combine, when you add so many cells or multiple cells, you form a battery. Then I gave some examples of primary and secondary cells. I said that Daniel cells and Leclanché cells are primary cells. Then the lead acid accumulator and the alkaline cells are the secondary cells. Then in the last episode, I talked about the simple voltaic cells and voltaic cells generally. Ladies and gentlemen, everything we'll be doing so far, both primary, secondary cells, or all these cells you are seeing, they are actually referred to as the voltaic cells. Yes. Remember I told you that voltaic cells can either be primary or secondary. So these are voltaic cells. You can also call them galvanic cells. Galvanic cells. Or you can call them electrochemical cells. Cells. Which means when you hear all this Leclanché, this thing, primary and secondary cells, they are all under what we refer to as voltaic cells, or you can call them galvanic cells, or you can call them electrochemical cells. So, in all these cells, what is important is to know what they are, whether they are primary or secondary, what material is used in the cathode, which is the positive plate for electrochemical cells, while for electrolysis or electrolytic cell, cathode is negative and anode is positive. But for electrochemical cells or electric cells or galvanic cell, the cathode is the positive electrode and the anode is the negative electrode. And there is this shortcut I gave in chemistry under electrolysis, cryo. I said that in cathode, reduction takes place in cathode reduction, and oxidation takes place in the anode, cryo. Reduction takes place in the cathode, and oxidation takes place in the anode. Let's enter our business for today. Daniel cell. The Daniel cell is a primary cell invented by John Frederick Daniel in 1836. Now, the focus of this Daniel cell is to see if it's possible to look at the issue of polarization or a way of stopping polarization. And when you hear Daniel cell or Leclanché cell, the things that should come to your mind first is all those your wall clock battery, remote batteries, all those your big touch batteries, all those batteries you see, you hold, you press, you even break them, you see black stuff inside. That is what will come to your mind. They are not rechargeable. Ladies and gentlemen, for Daniel cell, the EMF produced is about 1.00 volts. EMF is simply the potential difference when a circuit is open or when it is not delivering current. It is the voltage when there's no current in a circuit or in an open circuit. Or in other words, if you have a battery like this, the voltage delivered by that battery, the power of that battery before connection, that voltage it is delivering, that is simply the EMF. So it can deliver about 1.00 volts. That is for the Daniel cell. And Daniel cell keeps a steady current. That is what actually differentiates it from Leclanché cell. For Leclanché cell, it does not keep steady current, and the EMF of Leclanché cell is obviously more than that of the Daniel cell. For Leclanché cell or Leclanché cell, whatever you want to call it, just know the spelling. The EMF is about 1.5 volts. Daniel about 1 volt. Then for Leclanché cell, the polarizer is used. However, this depolarizer gets weak when the current becomes larger. This is like what you should know, side talk. Now looking at the lead acid accumulator, it was invented by Gaston Platé in 1859, while the Leclanché cell was invented by George Leclanché in 1866. Most of these guys, they actually named these things based on their name to keep the name running. Now for the lead acid accumulator, the EMF is basically greater than 2 volts, and it must be left below a certain level on discharge. If it goes below that particular level, it may not work. It will be difficult for you to charge it. I don't know if this explanation is actually right or makes sense, but look at it. The car battery is a good example of the lead acid accumulator. If your car battery runs down, it will not be able to start your car, and your car will not be able to charge that battery if it goes below that particular level. You start, it doesn't work. So what do? Since it has gone below that particular level and it's not able to charge from that level, you look for somebody. Sir, abeg, please give me your battery to use. So you pick that person's battery, put in your car, then you start the car. Your car now starts working, right? It's now on. You now put this your battery inside and plug them. So with that, with time, the battery will be able to pick. But at that low level, it will not be able to charge up and start up your car. Meanwhile, for alkaline cells, take alkaline cells to be your phone battery. And yes, phone batteries and most of those batteries in these gadgets, even if it runs down, after 2 days you plug it, it's going to plug, it's going to start charging. You don't need to remove it, or you don't need another battery to put in your phone first to boost your phone, then remove the battery and put. No, it won't work like that. So alkaline cells, they can supply large current and they can be discharged for long period of time without spoiling. So this can supply larger current than any of these cells. Now alkaline cells is something I really want to talk about. Alkaline cells is a name that comprises or carries about 3 major cells. One of the major example of alkaline cell is the nickel ion cell, NiFe cell, nickel ion. Another major name is nickel cadmium. Another major name is lithium ion. Nickel ion NiFe is used for your phone batteries. Yeah, I think laptop batteries can actually make use of that as well. Now in the modern days, these nickel ion batteries are now being replaced by nickel cadmium. Then we also have the lithium ion battery. So the difference between all these is actually the cathode use, the anode use. The electrolyte is the same. It's basically an alkaline solution, a base, which means for secondary cells we can have acid cells or basic cell. Alkaline are soluble bases. This is just an overview. So now let me treat them one after the other. Daniel cell, invented by John Frederick Daniel in 1836. This cell was invented to try to look at the issue of polarization, and the EMF is about 1 volt and it can keep a steady current. For Daniel cell, The positive electrode or the cathode is copper container, while the anode is zinc rod. The electrolyte is either copper sulfate and zinc sulfate, copper tetrahydrosulfate 6 or zinc tetrahydrosulfate 6. Look at it. If you have the copper rod here, you have the zinc rod here. If you are going with this first one, which is copper sulfate and zinc sulfate, the first container here, this electrolyte, can be copper sulfate. This one can be zinc sulfate. They are separated, different containers. Then to ensure neutrality or movement from one to the other, you put a salt bridge here like this. This is valid. Or if you want to put everything in one container, you can say, okay, I don't want to use 2 electrolytes, I want to use one like this. You can just put one container like this and put your electrolyte H2SO4 inside. This is also going to work. So remember I said cousin son. So for Daniel cell, anode is copper, cathode is copper, anode is zinc, cousin. Electrolyte copper sulfate and zinc sulfate. Then the depolarizer used in Daniel cell is copper sulfate, CuSO4. Leclanché cell, organized, invented, first popularized by George Leclanché in 1866, is of two types. We have the wet Leclanché cell and we have the dry Leclanché cell. It keeps unsteady current. The EMF is about 1.5 volts and the depolarizer is weak for large current. Now for the Leclanché cell, whether wet or dry, the cathode and the anode are the same. The cathode is basically carbon rod. The anode is zinc rod. Carbon and zinc, copper and zinc, carbon and zinc. The only way or the only area we have discrepancy, disparity, dichotomy, differences between the wet and dry Leclanché cell is in the electrolyte used. For wet Leclanché cell, the electrolyte is ammonium chloride solution. While for dry Leclanché cell, electrolyte is ammonium chloride paste. Solution means dissolve in liquid or in water. If you dissolve ammonium chloride in water or in liquid and you use it as an electrolyte in Leclanché cell, you simply say, wow, that is a wet Leclanché cell. For dry Leclanché cell, the electrolyte will be molten or paste, like toothpaste paste, not really liquid, of the ammonium chloride. Then we say, wow, this is dry Leclanché cell. And the depolarizer used in Leclanché cell is manganese oxide, MnO2, manganese oxide. The lead acid accumulator was founded by Gaston Platé in 1859. The EMF is greater than 2 volts and it must be left below a certain level on discharge. The cathode for lead acid accumulator is the lead oxide, PbO2. Cathode is lead oxide, anode is lead. So lead oxide, lead, and the electrolyte used is dilute H2SO4. For the alkaline cells, let's start with the nickel, nickel ion. The nickel ion battery, for the cathode, we have the powdered nickel hydroxide. That is what we use as cathode for the nickel ion cell, which is an alkaline cell. The cathode is powdered nickel hydroxide. While for the anode, we use powdered iron in steel tube. Powdered iron is used at the anode, and the electrolyte is KOH, potassium hydroxide. That is for nickel ion. How about lithium ion? For lithium ion, ladies and gentlemen, the cathode will basically be lithium oxide hydroxide and the anode will be the same iron, powdered iron, because we have lithium and iron. The first name here is what will basically be at the cathode. The second name is what will be at the anode. For nickel ion, there will be nickel and ion. Nickel in the cathode, iron in the anode. For lithium ion, lithium something something oxide or lithium oxide hydroxide will be in the cathode, and iron will be in the anode. Then the electrolyte can be the same, a base or an alkaline, soluble base. For this, we are using caustic potash. How about for nickel cadmium? For nickel cadmium, basically the cathode will be something of nickel and the anode will be something of cadmium. In this case, for nickel cadmium battery, the cathode is nickel ion hydroxide, nickel oxide hydroxide, NiOOH. This is nickel oxide hydroxide. That is the cathode for nickel cadmium battery, the modern battery used. And the cathode is, the anode is cadmium. The cathode is nickel oxide hydroxide and the anode is cadmium, Cd. Ladies and gentlemen, I hope you understand this comparison. If you have any question, let me know. And let's see other things you should know when it comes to these cells, these batteries, secondary cells, these voltaic cells. When it comes to discharging of lead acid battery, discharging means the battery is delivering current. There is supply of current. This is what happens during the discharging of lead acid. At the positive plate, hydrogen is oxidized into water, and the lead oxide is reduced to the lower oxide of the lead, and this lower oxide of the lead will react with acid to form lead tetraoxosulfate 6, PbSO4. Now, at the negative plate, the lead goes into solution to form lead sulfate. The acid or electrolyte diminishes in strength as it is dilute with the water formed at the positive plate. The reason I wrote this out is, in case you feel it's important to you, you can copy and look at them. They are basically by the wayside. And these are the effects of discharging. The first is evolution of gases and formation of salt at the plate. When discharging is taking place, there is a chance of the gas to evolve and salt to be formed at the plate. And there is evaporation of the electrolytes. As the electrolyte evaporates, it becomes more dilute and dilute, meaning it is getting less concentrated. And there is conversion of chemical to electrical energy, which is basically the function of the cells to convert chemical to electrical energy. And as such, EMF will begin to fall slightly. And maintenance of cells. The alkaline cells basically does not need much maintenance. They don't need much maintenance. Because even if you discharge the cell, you can plug, it comes up again. So when it comes to maintenance of cells, we are basically more concerned about the acid cells. So these are things you should do. Avoid over discharging. Shorting of terminals or wrong connection should be avoided. You're supposed to connect positive to positive and negative to negative. Don't miss connections. That is a bad practice. And you should top up the charge regularly. Always top up the charge and try to clean the battery terminals. That is it. Then, arrangement of cells. Cells can be arranged in series or in parallel. For series, you are connecting them to each other like this. They are joining them. And when you are solving for series connection of cell, it's the same way you solve for series connection of resistors. If you have a series arrangement of cells E1, E2, and E3, the total EMF or the total equivalent EMF is simply the sum of all the cells. And parallel arrangement of cells is, let's say you put one on top, put one down, put one here, or You are not putting them in straight line. So even as you are putting some up or some down, positive to positive, negative to negative, positive to positive, negative to negative. And solving in that way, we solve the way we solve for resistor as well in parallel. 1 over the equivalent EMF of the cells will simply be 1 over E1 plus 1 over E2, like that and like that. Ladies and gentlemen, I already selected certain questions, past questions under electric cells. But the way it is now, I'm not going to answer any of them again. I'm not going to answer them. Yeah. So get your Flashlearners applications, go to cells. Yeah, you see electric cells, all the topics that have to do with electric cells in the application. Click all of them under practice with topic. Answer all the questions. They are actually very easy and understandable. And I've explained everything you need to know. Okay, I will still think if in the next episode I don't answer questions, past questions under electric cells, know that I'm not going to do that. If I do it, know that I change my mind. But see you in the next episode.